R2D2 here with me today to solve rational equations. So today we're trying to figure out what is x? What is the variable that we're trying to solve for? When we're solving rational equations, I'm going to show you two different methods for solving today. Notice in this problem that when we have rational equations, this is really just a big division symbol. And how do we get rid of division? How do we undo division? Well, we multiply. So that's what we're going to do first. First, to get rid of this, I can multiply by 4x. And what I do to one side, I have to do to the other side. So when I multiply 4x times this fraction, it cancels it. So this is 2x plus 4. And then when I multiply it times this fraction, I do 1 times 4x is 4x over 3. Now I want to get rid of this division symbol. So I'm going to multiply by 3 on both sides to cancel this out. Alright, so now I'm going to distribute 3 times 2x is 6x, and 3 times 4 is 12. Now we have a simple equation to solve, right, R2? We know how to do it from here. We're going to subtract 6x. He really felt confident about that. And that is negative 2x. And divide by negative 2. And x is negative 6. I just want to show you one shortcut up here. If you notice that we always multiply by the denominators, you can actually do this in one step. You can cross multiply. You can multiply 3 times 2x plus 4 and 4x times 1. And you can skip straight to this step. So R2, if you're trying to cut to the chase, you can just cross multiply when you notice you have something divided by something on both sides of the equal sign. So that's one method for solving rational equations, but it only works if you have a fraction equaling another fraction. All right, in this scenario, notice that we have two addition signs. Remember, when we're adding and subtracting, our first job is to get a common denominator. So that's what we're going to do here. I'm actually going to look across the entire problem and see if I can get a common denominator that will match all of these. Well, I notice I have a 10, which I could get with the 5, and I have some a's. So if I shoot for my goal to be 10a all the way across, then I will have a common denominator all the way across. So let's shoot for that. I chose that because all of these could multiply up to 10a. So I'm trying to choose something that they all would be able to multiply up to. So for example, I can multiply this one times 2a, and it'll equal 10a. So I'm going to multiply the top times 2a. This one, I need to multiply by 10 to get it to be 10a, so I'm going to multiply it by 10, which means I need to multiply the numerator by 10 to get 40. This one, I need to multiply by a. 1 times a is a. The last one, I need to multiply by 10 to get it to be 10a, and that's 70. I agree, R2, that's a lot. All right, now we have a common denominator all the way across. So if I multiply everything, all of this by 10a and all of this by 10a, then 10a divided, cancels, cancels, cancels. 10a, this is canceling out the division here as well. That way, all I'm left with is 2a plus 40 equals a plus 70. Now we're down to a simple equation that you guys already know how to solve. So I can minus the 40 to get my like terms together. And 2a equals a. 70 minus 40 is 30. Get the a's together by subtracting a. And 2a minus 1a is a. So a is 30. Now there's one last step that we need to do when we're solving this is we're gonna plug in 30 for A. We wanna make sure that it doesn't cause us to divide by 0, because remember, it's illegal in math to divide by 0. So 30, right here, you're right, R2, we can't divide by 0. So we're gonna put, if A is 30, then it's gonna be okay because it's not dividing by 0. And this A could be 30, it's okay. The only thing this A could not be is 0. So we are okay in this problem. A is 30. All right, R2, this is our last problem for solving rational equations. Remember, when we're adding, we first have to get a common denominator. So when I look at this denominator and this one, I see that they're all very similar. And in fact, if I made them all look like this, then we would have a common denominator across the board. So I'm going to make that my goal. I'm going to have this be x minus 2, x plus 2 times x minus 2. This one be x plus 2 times x minus 2. And this one is already there. All right, so I know that is a big common denominator, R2, but that's what we got to do to get them all to be the same. So, in order to get this to be this, I have to multiply times x minus 2, because that's what it's missing. So I'm going to multiply by x minus 2, top and bottom. And then x times x is x squared. X times negative 2 is negative 2x. All right, let's look at our next fraction. For this denominator, all I'm missing is the x plus 2. So I'm going to multiply this by x plus 2 for top and bottom. 2 times x is 2x. 2 times 2 is 4. All right, last one. The denominator is already correct, so we are going to go ahead and just bring down the numerator. Now here's where the magic happens. If I multiply the entire problem by x plus 2 and x minus 2, all this divided by this, divided by this, and divided by this will go away, because I'm going to multiply everything times x plus 2 and x minus 2, which will cause this to cancel, and this to cancel. So now I am left with x squared minus 2x plus 2x plus 4 equals 2x plus 12. So it's still a big mess, but we're getting closer. So now we're going to try to combine our like terms, and I notice that I have a square here, which tells me that I'm going to have to either factor or use the quadratic formula. So I'm going to try to get it equal to 0. That way I'm going to be able to factor it here at the end. So I'm going to minus the 2x over here. When I minus, I've got these two. When minus 2x and 2x combine, that's going to cancel. But I'm also going to minus this 2x over here. And I'm going to minus the 12 over here. Notice that I'm putting it under the like term, because that's what I'm going to combine it with. All right, so I'm going to bring down the x squared. I have a negative 2x here and a negative 8. Remember, I already took care of this 2x right here, so I'm left with 0. All right, so we're going to factor it. I'm looking for two numbers that multiply to negative 8 and add to negative 2, which would be 4 and 2. So this factors to be x minus 4 and x plus 2, which tells me that my solutions are 4 and negative 2. Now, our very, very last step is to check to make sure that neither of these are extraneous solutions. What I mean by that is when I plug them back into the original problem, it cannot cause me to divide by 0. So if I plug in 4, we're going to be okay. But when I plug in negative 2 right here, negative 2 plus 2, you're right, R2, 0. That's undefined. We can't do that. So we know This is an extraneous solution. It does not count. X equals 4 is our only solution. So what X could not be in this problem is it could not be -2 and it could not be +2. So if we've gotten +2, that also would tell us that that's an extraneous solution because we can never divide by 0. So let's review our steps. We always want to work to get a common denominator first. Then we multiply by that common denominator so that we can clear it out. And then we solve just like we did every other algebra problem. And then we always check our solution to make sure that it's not an extraneous solution. And that's it for solving rational equations. Make sure you practice these because there's a lot of different kinds of problems, but if you practice them, you'll start to get the hang of it. Good luck, guys.